Hello everyone, welcome back. I hope you had an amazing week. Here we are. Today is our last session, or session number 30. There have been 3 amazing week with you guys. I'm really excited to see that all the things we have done throughout the year. And good luck in your exam. So let's do the last session, 33. In the diagram below, shows a circle with an inscribed right triangle and some of the measure in units. Based on the diagram, what is the circumference units of the circle? Okay, to know the circumference, we have the formula. Circumference equal to pi r. Or if we want, or either way, pi d or diameter pi. But generally we use the 2 pi r, so I'm not going to change it now. It's a one more step, but it will be fine. Now, um, we need to calculate r. This is the diameter, so I can use Pythagorean theorem. I have that c squared can be equal a squared plus b squared. They're saying this is a right triangle, so c squared will be equal 8 squared plus 6 squared. So c will be equal to square root of 8 squared 64, 6 squared 36. 64 plus 36 is 100, and square root of 100 is 10. So C, which is diameter, will be equal to 10. Now the diameter is equal to R. And as you can see here, we have 2R. So I can say that 2R pi, the circumference is 2R pi. We have we have 2R, which is 10, so circumference is 10 pi. And that's it. Now, consider the circle with a radius of 10 inches and a central angle that extends an arc of x. Select the proportion that can be used to find the length r. So we're using the length. So we are using the formula, the x over 360 times the circumference, because it's the length. So it will be 2 pi r. R here is 10, so 10. So that's basically it. I'm looking here, and okay, they have it in a different way. So I have the circumference equal this. They have it in a different way. They have it like a proportion. Um, Basically what I say is that this is the length of the arc right here. So C, let me move this to another place so you can see it. C, circumference of the arc, which is the length of the arc. So length arc. Now, if I divide both sides by 2 pi 10, 2 pi 10, 2 pi 10, I can cancel out here, and then I have that n over 360 equal length arc over 2 pi 10. And here n is just the angle, which in this case is x. So let me look here, have x 360. This is not right because we have the length of the arc at the top. We have the length of the arc at the top. Here we have the length of the arc at the top, this at the bottom, but then we do not have um we have this one wrong. We have 360 over x. So not fine. Now in this case, where this 100 thinking from? It just doesn't make sense. Now look at this. This is a new variation. I discard the other three. This should be the answer. How can I prove it? I can cross multiply. If I cross multiply this, or basically I interchange, I'm just gonna do it one side. I can interchange this, so I can say this is totally valid. I just multiplying both sides by 360 and multiplying both sides by 360. And then dividing both sides by the length. So this cancels here, this cancels here. And then I have that x over length is going to be equal 360 over 2 by 10, which is exactly what we have in choice D. Now, let's see this one. Assume there's a circle with a radius of 5 inches. Okay, circle and the radius is 5. And highlights an arc of the circle that measures 18.5 inches. Okay, 18.5 inches. I'm going to say, okay, wait. I'm going to say that this totally not a scale is 18.5. What is the measure of the angle? 20 degrees. So we know that the measure of the, like, we know that the arc, so arc length is going to be equal angle over 360 times the circumference, which is 2 pi r. And the r right here is 5, so 2 pi 5. So I can move, and I have that the arc length is 18.5, so 18.5. So I can multiply both sides by 360, so 18.5 times 360 is 6,660, so wait, yeah, 6,660 is going to be equal the angle times 2 times 5, 10 pi. And now we need the 6,660 divided by 10 pi, 10, oops, divided by 10 pi. Don't forget to put the parentheses. Very important. If we don't put the parentheses, we don't get the right answer. So, parentheses. And approximately this is 212. So, n is approximately 212. And this is an n, which is option C. A gardener plants new grass in the shaded area shown in the diagram. In the diagram, point R is the center of the circle. The gardener puts a rope around the entire perimeter of the shaded area. To the nearest foot, what is the length of the rope? So we have, wait, we need to find the perimeter. So we have this side, oops, we have this side, it's going to be 60, because this is also the radius, this is also going to be 60, and we are missing this. So we need the arc length. The arc length will be arc length to be equal the angle, so 100 over 360 times 2 pi r, and the radius is 60. So and, we can put all this in a calculator. We can go step by step. Our length equal 100 over 360. 100 over 360. Okay. we do not have an exact number, so I'm just going to put over everything. So 100 over 360 times 2 by 60. 2 by 60. And that's approximately 105 because I'm rounding to the nearest number. So approximately 105. 105. So we need the perimeter. So the perimeter will be equal to 60 plus 60 plus 105. And 60 plus 60, 120 plus 105. 120 plus 105 is 225, which is option C. Now here, Juan is making a daily schedule clock to help with his time management. Every day between 4 and 6, he should work on homework. He's just using a radius of 12 inches. What is the approximate area shaded of the shaded homework sector on the clock? So we need to find the area, and we have 12 inches. Oops, 12 inches here. We know that the area of the sector will be equal, sorry, angle over 360, and the area of the circle, which is pi r squared. Now, we don't know the angle. However, this is a clock. This is divided in equal parts. So this will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. There are 12 spaces that are equal. So if I do 360 divided by 12, I will get the value of each part. And if I'm not mistaken, this is going to be equal to 30. Go back, check. 6 divided by 12, 30. Now we have two spaces. We have one here, one here. So the angle will be 30 times 2. If we have two spaces, that is going to be 60. So our angle right here will be 60. I come back, when I substitute the values, I have that the area of the sector will be 60 over 300 times pi r squared, and r is 12, so 12 squared. Area of the sector is, I can simplify this, it will be 1 over 6, or we can just leave it over 360 times pi. 12 squared is 144, so 144. We can go to the calculator, we can put everything, so 60 over 360 times 144 pi, and that's approximately 7. What is the approximate area of the globe, which is 75.4? Yes, that's exactly what we got. Now here we have this diagram. It models a projectile of light. The sector has a radius of 38 miles and an angle of 102 degrees. Determine and state the area of the sector. Again, we have the area of the sector will be equal to the angle over 360 times the area of the circle, which is pi r squared. Now, the angle, they give everything to us. So we have that the angle is 102. So area of the sector will be 102 over 360. And then we have that the r is 38. So times the pi 38 square, and then 38 square. So I'm going to my calculator. I have a 102, and then here I have 38 square times pi. and that's approximately, do they say to round to the nearest square mile. So this is approximately 10285 because 3 is less than 5, so we keep the same number. So 1285 is the answer. 1285. Very easy. Now let's look. Okay, this is going to be, well, let me not talk. Okay, 79. The design of arc shape. Okay, we have the arc. 134, 144 degrees. We have the radius 2.3 meters, so this is 144, and the radius 2.3. And they're asking for the length. Okay, the length, we have the arc length going to be equal the angle over 360 times the circumference, the length of the circle, which is 2 pi r. So that will be equal 144 over 360 times 2 pi on the r was 2.3, so 2.3. We go here, we say 124 times 2 pi times r, which is 2.3. Yeah, and that's they say round to the nearest tenth, so 8 greater than 5, so it will be 5.8. Approximately 5.8, which is choice C. Now here, a sector of a circle calculator being, a sector of a circular theater is being reserved for season ticket holders. The sector is represented at the shaded portion of the diagram below. Find the length of roping needed to extend across the back of this section of the theater. So basically, they want the length of the back, which is going to be this part right here. What is this part right here? This is the circumference. Do we know the formula for the circumference? Yes. Well, the arc length of the sector. So, sorry, that will be equal the angle, which is 80, over 360 times the circumference, which is 2 pi, and r, which in this case is 40. So we go to calculator. We put it there. No, 80 over 360, and then 2 pi from the radius, which is 40. And that, what they say, they round to what? Round to the nearest hundredth of a foot. So it will be 200, like 10th is 1 after the point. 100 is 2 after the point. So we have a 0 after, oops. We have a 0 after the 5, so we just keep the 5, and that will be 55.85. And then each seat in the tier occupies approximately 7 square feet of the floor space. How about how many seats are there in the session for a season ticket holders? So we have, okay, this is the length. Now they're asking about the area. They say that each seat occupies 7 square feet. Square feet area. So we need to calculate the area. So the area will be the angle, so 80 over 360 times the area of the circle, which is pi r squared. And in this case, r is 40, so 40 squared. We go back and we say pi times 40 squared, and that's approximately 1,117. 117. Now they say that each chair occupies 7 square feet. So I need to divide the whole area by 7. And that's approximately 159.6. Now, can we put 0.6 seats in the theater? No, we cannot put 0.6. Like we can put 159. That 0.6 extra, we cannot put the shares. So that will be, we need to put 159 seats because the point 0.6, there is only 0.6 share left, like a space for a 0.6 share that doesn't exist. Now, part C. An opening night for a play. There are 221 reservations for season ticket holders. The theater manager decides to expand the sector by creating a larger central angle. What is the measure to the nearest degree of the near angles? So basically we have 221 seats. So we need an area that could fit 221 seats. We know that each seat is 7 um 7 feet, like square feet. So we need to multiply 221 times 7. Go to our calculator. I'm gonna use another one so I don't delete that one. So 221 times 7 is 1547, equal 1547. Now this is the area that I need. This is the area that I need. So I'm gonna say that the area, which is 1547, is going to be equal to the angle over 360 times pi r squared, which r is 40, so 40 squared. Now 40 squared is going to be equal, I can multiply 360 on both sides. So this is 55, 69, 20. So 55, 69, 20 going to equal the angle time 40 squared is 1600, so 1600 pi. Now I can divide 1600 pi in both sides. So divide by 1600 pi. Let me put the pi here. So this is approximately 111. So the angle will be approximately 111. Because 7 is greater than, like 7 greater than 5, so we add 1 to the one before. 111 degrees. And that's our answer. Now, 81. Cinnamon City Council decides to create a circular garden in the center of the park. After consulting with an architect, the council decides that the garden will have the following specifications. A radius of 10 feet. Okay, let me draw it. Radius of 10 feet. Divides into 3 sectors. Shaped like a pie slice with a central angle. So sector 1 is 144 degrees. So sector 1, 144 degrees. For the tulips, so T. Sector 2 is yellow roses. So I'm just going to put roses. And then sector 3 is daisies. I have a central angle of 90. So this approximately will be sector 3. It's going to be 90. This is 144. Let me put it right here. This is 90. And this is the daisies. So this is my drawing of the garden. So the gardener needs to fence in the tulips to the nearest 100 of the foot. How much fencing will the gardener need to surround that sector? Okay, I'm looking at the tulips. It's not only the arc line, it's also the sides. So we need the perimeter but for the perimeter we need the length of the arc. Let's use your formula. We have that the arc length going to be equal to the angle, which is 144 over 360 times 2 pi r. So 2 pi, which is the circumference, r, which is 10. Now we do put this in our calculator. So 144 over 360 times 2 pi r. R was 10. That's approximately 25.3. However, however, if we round this to 25, there is always something greater like after that. So if we round to 25, we're going to be missing 0.1, and then that 0.1 won't have fencing, like won't have a fence. So in this case, we want to make sure that every space have a fence, so we need to round up. So it will be 26. It's just because of that. And we need to round to the nearest hundredth of a foot. So it will be 3. We're going to round up because we want to make sure that all the space, like we have more thing here. Then if we don't include this, then we won't have fence for 0.0027 for like part of the space. So that's basically why we're rounding up. So it will be 25.14. So 25.14. Now 25.14 plus 10 plus 10, because we need to add the two radii. So 28, 10 times plus 10, 20, 20 times 25.14, that's 45.14. Now B. Each rose bush takes 3 square feet of a ground. Approximately how many rose bushes will the gardener need to plant to cover sector 2? Okay, we need to find the area of sector 2. Now, do we have the angle? No, but we have the angle of the other two, and we know that 360 minus 144 minus 90 will give me that angle. So I'm going to my calculator, and I'm putting 360 minus 144 minus 90, and that's 126. So my angle of sector 2 is 126. And now I can calculate the area of sector 2. So area sector is going to be equal, in this case, 120, the angle is 126 over 360 times pi r squared. So pi r squared, and r here is 10, so 10 squared. I'm going to my calculator, and I put in 126 over 360 times pi times 10 squared. And that's approximately 110. We we need to round. Okay, I'm just going to say approximately 110. Now I need to divide this by 3 because that's what we're looking for the rose bushes, and the rose bushes are 3 each. So I'm going to divide by each rose bushes, and then our answer should be 36. Why 36 and not 37? Because of the same thing I said before. We cannot plant 0.65 of a rose. If we're going to plant the rose, we need to plant the whole rose. If we don't have a space for a complete rose, we don't plant it. So we can only plant 36 rose bushes. The other 0.65 is just free space that we don't have to plant a whole rose bushes. No. The next year, the council decides to enlarge the garden by increasing a radius from 10 to 25 feet. That will, wait, that second year, how much total fencing will the gardener need to fence in the tulips, and how many rose bushes will she need to plant? So again, we do the same here, but now we change the radius. I'm going to do the rose bushes first because I have the, oh, never mind. Never mind. So I have the the area, the length of the arc length. I have the arc length of the tulips. It was the tulips. Yes, here's what we did in part A. Now I'm going to substitute the 10 by a 25. So I have 144 over 360, oops, times 2 pi, and the r is 25. So 2 pi times 25. And that's approximately 62.84. Remember, we are rounding up because we need defense. I explained before. So 62.84. And just keeping the same values we use here. So 62.84. Now we have the radius, and the radius will be 25 and 25. So it will be the perimeter will be 62.84 plus 25 plus 25, and that will be equal 1012.84. So that's our answer. Now here the rose bushes. We are changing the radius and we are using 25. So we have 126 over 360 times pi radius squared. So 25 squared. And that's approximately 287. Now we need to divide by 3 because of the rose bushes. And now we have a space for 229 rose bushes. The extra space is just free space. Now 82. A tile manufacturer wants to create a set of those circular tiles that are painted in various colors. A sector of the tile has a radius of 4 inches and a central angle measure of 65 degrees. Okay, find the area of the sector of the tile. So we have everything we need. The area of the sector will be equal to the angle, which is 85 over 360, times the area of the circle, which is pi r squared. So it will be 4 squared. So we go to our calculator, and that will be 65 over 360 times pi r squared, so 4 squared, and that's approximately 9. Let me see where we have to round it to the nearest square inch. Oh, um, yeah, the nearest square inch, and so approximately 9. The answer is 9. Now, the cost to manufacture the paint, the, to the manufacturer to paint the tiles is 0.07 per square inch. How much will it cost to paint the set of 250 tiles? A set of two. Okay, let me. What? Okay, let me see one thing. Okay, I think that it will be a radius of 250 tiles. Give me 1 second because I don't know the meaning of the word tile. Sorry about that. Okay. Okay, now I know. Okay, now, yeah. So basically, circular tiles that are painted in various colors. What I understood is that sorry, my English sometimes is not helping me. So it will be one tile, and then around it will be around another tile for other color. So I'm supposing that it means that 250 tiles, circle tiles that are primary color of the tile has a radius of 4 inches. Okay, that's what I'm thinking. So, um, uh, I'm going to you calculate the area. So area will be equal. We have the radius. We just need the area of the circle. We don't have a specific sector. So it will be pi r square. So pi to 50 square. Weird. Pi to 50 square. This big number. And now each square inch is 0.07. Then you're going to multiply it in 0.07. And we got $13,000. And we need to run to the nearest dollar. So 4 is less than 5, so it will be 13,744. If I'm wrong, please let me know in the comments in Discord or whenever you guys can. This was a weird, probably was a weird one. Now circle A is graph. Okay, which sequence or transformation maps circle A onto circle B? Okay, so let me see. This 96 is 94, so it will be 5. Then 4, 3, 2, 1, 0. And then 1, 2, 3, 4, and 5. So it's 5. And it is going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to the right. And then it is going 1, 2, 3, 4, 5, 6, 7 down. So first 10 to the right, 7 down. Okay, this is not reflection. Could be, but we have 7, and we have 10 to the right, 7 down, and then we have a dilation times 2. Let's see if that fit. Here we have 1, 2 as the radius, so let's see if we have a 1, if we have 4 as a radius. So here we have 1, 2, 3, 4. So yeah, 4 is 2 times 2. So it seems that it is choice C. Now let's see here. Circle A and circle B are shown. Which sequence or transformation map circle A onto B? Well, I can say it is 1, 2, no, 1, 2, 3, 4, 5, 6, 7, 8. 8 to the right. Do we have that? Okay, we have already translated 8 to the right. 8 to the left? No, it's not E. It cannot be E. Now, 8 to the right, we have it here. And then dilation by a factor of 1 over 3. Let's see. We have A, and this is 3. So the radius 1, 2, 3. And here in B, the radius 1. We multiply 3 times 1 over 3. That will be equal 1. So this seems totally fine. Dilations by a radius of 1 over 3. And now this it says select all the transformations. So first we know that E is not. We know that the dilation is not 3. And we know the dilation. We know that the dilation is 3 is becoming smaller. So let's see. Could D be an answer? Could A be an answer? And dilate circle A by a factor 1 over 3. Okay, perfect. Then rotate it counterclockwise about the origin by 180 degrees. Yeah, that's perfect. 180 degrees will be exactly this. If we're here, 180 degrees will be in the other side the same. So that's exactly what is happening here. It is 1, 2, 3, 4 away from the origin. 1, 2, 3, 4 away from the origin. So we do have a rotation by 180 degrees. Now let's see. Can D still be? And then rotate it counterclockwise about the origin. Oh, now I say clockwise. The thing about it is that clockwise and counterclockwise and 180 degrees is exactly the same. So if we do it, we are here, and we do it counterclockwise, is exactly how I did it. And clockwise will be like this. We still get to the same place because it's 180 degrees. So this is also true. Now let's see 85. Oh, this is the last one. We use the following transformation will map circle A to circle B, so let all that apply. Okay, A to B. I have 1, 2, 3, 4. This is the center. Okay, so 4 right. Then 1, 2, 3, 4, 5 down. 4 right, 5 down. Okay. 4 right, 4 right, 4 left no, 4 right yeah, 4 left no. So we're leaving there, 5 down, 5 down, 5 down. Perfect. We have A, B, D. Now let's see. Dilation of. Which dilation is right? Is it becoming bigger or smaller? That's a real question. It is becoming bigger. If we see here, this is greater than 1. This one is smaller than 1. And this one is greater than 1. If it is smaller than 1, I'm going to cross out because it's becoming bigger. And to make it bigger, it needs to be greater than 1. Now, as you can see here, I know these two are right answer because they have the same dilation, which is 3 over 2. So I know they are right answer because it is the same dilation. Now we want to know which, if they say one side 3 over 2 and the other side 5 over 4, how do we know it? Okay, let's see. This is the radius and this is the radius of 2. If I multiply 2 times 3 over 2, 2 times 3, it is 6, and then 6 divided by 2 is 3. Let me check the radius here. 1, 2, 3. I got it. Now you want to check the other one. It was 2 over 3. 2 times 2 is going to be 4. 4 over 3. You cannot divide it. You're not going to get a specific number. So that's how and also this is smaller than 2. Like 4 over 3 is smaller than 2. So it will make it even smaller. Yeah, that's all. Then we finish. I hope you guys had like understood. If you have any questions, this course is still there. I'm open to answer any question you might have. If not now, next year, whenever you want. So just ask me if you want. Good luck in your test. Thank you. Thank you for all this year long. Bye.